All. This is Surya from Dr.SNS Rajalakshmi College of Arts and Science, working in Department of Computer Science, Full Stack Web Development as Assistant Professor. Today we are going to see about operating system deadlocks. Deadlock and starvation. Deadlock is a scenario in operating system where two or more processes are unable to proceed because each process is waiting for resource that is being held by another process. This situation creates a standstill where no progress can be made until the deadlock is resolved. Here the diagram is given for that. Resource 1, resource 2, process 1, process 2. On waiting load and assessment load. Internal and design principle. When two trains approach each other by crossing, both shall come to full stop, neither shall start up again until the has gone. Statue passed by Canada State Legislature early in 20th century. The Treasure Railroad broke. And here, Hallox, this chapter continues a survey of concurrency by looking at two problems. Palek, all efforts to support concurrent processing, deadlock and starvation. We begin with the discussion and underline the principal deadlock and related problem of starvation. Then we examine the three common approach of deadlock, dealing with deadlocks, prevention, detection and avoidance. When then look at one of the classic problems used to illustrate both synchronization and deadlock issues, the dining philosopher problem. The permanent blocking of set of processes that either compete a system with resources or communicate with each other. A set of process deadlock when each process is set in a block awaiting there can trigger another block process in the set. Permanent no efficient solution deadlock and permanent blocking a set of either compete of a system communicate with each other. A set of processes decline and then blocked awaiting an event. Deadlock is permanent because none of the event is ever tried, unlike the problem concurrent management. Here, no efficient solution in general case. I need a quad A and B animated slide click one cars approach interaction. The car announced their resource needs. All deadlock involves conflicting needs to resource by two or more processes. A common example to traffic deadlock shows a situation four cars has arrived in the four-way stop interaction approximately same time. Four quadrant interaction and the resource over which control is needed. Here the four cars go straight. Car 1 travel north, needs quadrants of the B, and car 2 needs quadrant B and C, and the car 3 quadrant C and D, and car 4 D and A. The typical rules of the road United States is four-way stop should differ, car immediately at the right. This rules works 2 or 3 cars at existence. Halt until B is free, animated slide 1 car moves to deadlock. Then cars announce their resource. Need 4 cars ignores rules and procedures and but cannot proceed because the required second resource has already been seized by another car. Actual deadlock halt until A is free. In the previous example, the actual deadlock was not guaranteed to happen. For the example, if one of the car decided to stop rather than interaction to other car, 3 cars, like race condition, deadlock result particular sequence execution, blocking a set of process either computer systems resource and communicate with other. Deadlock is permanent because none of the event triggered and no efficient solution is general case. Can be safely used by one process on time and not depleted the use of process. I/O channel, mainly the secondary device and the destroyed interrupt signal messages, information I/O buffers and problem. Two general category of resources can be distinguished: reusable, consumable. And here the I/O channel maintain the secondary device. Consumable resource is one of the structure files, database, semaphores. An example consumable resource are interrupt, signal message, information in the I/O buffer. Reusable, and however one strategy dealing with the other deadlocks impose the system design and PO, P1, QO, Q1, Q2 and Q2. And thank you all